Okay, so today we learned about reflections on the coordinate plane. So for homework, we're going to flip the shapes over the y-axis and draw the image. We're going to label the corresponding vertices with the appropriate letters. And then to check our work, we can fold the paper along the y-axis. That's similar to what we did with the warm-up today. The two shapes should match exactly. So I'm going to start with point C, and I'm going to count how many jumps it takes to get to the y-axis. And it took 3. So I have to take 3 jumps out from that. That's the first point. So point C was located at -3, 5. That was point C. And now when I reflected it over the y-axis, it became +3, 5. So when I reflect over the y-axis, I can see what happens is that the x number becomes the opposite, but the y stays the same because we're reflecting over that y-axis. All right, so let's try it with point D. It's 1, 2, 3, 4, 5, 6 jumps to the y-axis. So 1, 2, 3, 4, 5, 6 jumps out. Let's try point B. 1, 2, 3, 4 jumps to the y-axis. 1, 2, 3, 4 jumps out. That's where the image of point B would be, kind of up on that mark. And then finally, we have point A. Now, point A might be a little hard to count because the shape is covering part of the coordinate plane, but we can imagine where it would be. 1, 2, 3, 4, 5, 6 jumps to the y-axis, which makes sense because it's right in line with point B. So we would take 1, 2, 3, 4, 5, 6 jumps out. Now we're going to connect the points. Yours is going to be a little bit better than this one here, because the smartboard's not oriented too well. But you can see that I have a trapezoid that should be an exact mirror image of the original trapezoid. So almost as if I were to hold up a mirror, this is what I would see on the other side. Okay, so you can fold your paper and see if it is, in fact, the same. All right, now let's try one where we're reflecting over the x-axis. So this is on the next page. We want to flip these shapes over the x-axis and draw the image of each shape. Label the corresponding vertices with the appropriate letters. To check your work, you can fold your paper along the x-axis. So which one should I do? The trapezoid again, we'll try. So I have the trapezoid here, and now I want to reflect it over the x-axis. So I'm going to be counting down to the x. So point D has 3 jumps to the x-axis. So that means I'm going to take 1, 2, 3 jumps down. So now if I look, the original coordinates of point D were -5, 3. So D was -5, 3. When I reflected over the x-axis, it became -5, -3. So we can see when I reflect over the x-axis, the x-coordinate stays the same. But the y-coordinate became the opposite, and that's going to be true of all of the points. So point C, 1, 2, 3, 4 points to the x. 1, 2, 3, 4 points down. All right, point B. Now again, part of the shape is covering the coordinate plane, so we're going to have to be careful here. We're going to have 1, 2, 3, 4, 5, 6 jumps down. 1, 2, 3, 4, 5, 6. That would be my point B. And finally, point A. Point A is 1, 2, 3, 4, 5 jumps down to the x-axis. So it's going to be 1, 2, 3, 4, 5 down. Whoops. So that would go right there. All right, our smartboard is not cooperating too well here. But if we wanted to connect all of our points, we would connect it like this. Oh dear. We should end up with a flipped over trapezoid. So let's see if we can't salvage this real quick. Our points are going to be -5, 5. So -5, -5. Those connect. And then I'm going to have, for point B, it was -3, 6. So -3, -6. And then for point C, it was -1, 4. So -1, -4. There we go. So this here is the image of my original trapezoid. Hopefully yours looks a little bit better because you can use straight lines and not have to worry about the smartboard. Okay, so this is the image. It looks like it's upside down because it should be upside down because it flipped, and it flipped over something. So just like if you take a coin and you flip it over, you see the opposite side. All right, try the homework and we will talk tomorrow.